In this screencast, I hope to clear up some of the confusion about working with circulation with demands and circulation with lower bounds. So let me just set the stage briefly with this slide that you've seen already. The idea with circulation is different than the idea with just plain maximizing network flow. Here you've got multiple demand nodes and multiple supply nodes. And the issue is it feasible to satisfy all the demand nodes with the supply nodes? And typically, if you want to get a circulation, that's a particular version of that problem, namely where the amount of supply added up over all the nodes is equal to the amount of demand over all the nodes. So it's very different in the sense that with max flow, you have an optimization problem. Here you have a satisfiability problem. So this slide is just to remind you what it means to have lower bounds on the edges. And what that means is that the flow over the edge has to be between the lower bound and the upper bound. So it's basically, if you're going to meet the lower bounds, in other words, if you're going to satisfy this inequality, it means that you're guaranteeing a certain amount of flow to go from the over that edge. So to deal with these lower bounds, what do? We basically change the amount of demand associated with the tail of the edge and the amount of demand with the head of the edge. So here we've got an edge from V to W. We've got a lower bound on that edge of 2. So what we do is we modify the demand at V, we make it increase by 2, and we subtract 2 from the demand at W. So in other words, this is increasing the amount of demand at B, and this increases, because it's minus 2, is increasing the amount of supply here. So it's basically guaranteeing that we're going to sneak, if you will, divide the pipe of 9 up into one pipe that's full of capacity 2, and the other remaining 7 is somewhat of a different pipe. But this is another way of saying that there's this imaginary pipe there that's carrying 2 units of flow from V to W. So now I want to try to make everything clear by revisiting our survey design problem. So remember this problem. We've got a certain number of consumers and a certain number of products. The idea is we're going to ask consumers questions about products that they own, and because we want the survey to be a reasonable length, it's got to be between C sub I and C sub I prime questions. And for the products, so we want to make sure that we have at least a minimum number of questions asked of different customers. So again, we're going to have a lower bound of flow between P sub j and P sub j prime. So here's our picture that you've seen now a couple of times. We've got over here on this side the customers, and we've got a lower bound on the number of questions C sub I that they can be asked, and an upper bound C sub I prime. And for the products, we've got a lower bound of the number of questions that must be asked on each product, and again an upper bound that would be we don't want more than that many questions, just from an economic perspective perhaps. Okay, then we can turn this in to a network flow problem, and ultimately our goal is to turn it into a circulation problem. Now the way we're going to do that is we'll add a source over here, and we'll send the flow up to the customers, over to the products, and down to the sink. And these edges in the middle, they correspond to whether a customer has been asked a question, can be asked a question about a product. So there's an edge if the customer bought or used the product. So the first thing we're going to want to do is get rid of these lower bounds. So now all we do is do exactly what was on that earlier slide. Because we have a lower bound here of C sub I, each one of these customers is going to have a source think of C sub I questions. Okay, and then back here, we're going to have a demand of the sum of all those C sub i's. Over here, we can think about it. Now we've got a demand for this many questions, P sub I, or J here, from the customers. And so we've got that for all of these, and then that means over here we're going to have a supply of those. So now we have a circulation problem. Now, one thing to remember is for the circulation problem to be, it's a satisfiability problem. So for it to be a satisfiability problem, we're going to need to get the supply over to here. So, and we also, if the sum of the C sub i's is not equal to the sum of the P sub i's minus P sub i's, then what's going to happen is we're going to need to do something to get them equal so that we actually can have a circulation. So rather than carrying around all those summations and stuff, let's look at a very specific example here. I'm going to have the C sub i's lower bound be 2, upper bound be 6, and the products lower bound be 2, and the upper bound be 4. Now, if you look at that particular example, and this would be true in general, you can see that the demand is going to be 10 questions, since we have 5 products, but the supply is only going to be 8 questions. So we're going to have to think carefully about how we're going to deal with that. And now we've gotten rid of the summations, but the sum of all these 2's is 10, so we're going to have a supply of 10 over here, and we're going to have a demand of 8 over here. And if you think about it, luckily that means that you're going to be able to send this is now the extra supply that we need. So now we're going to be able to send that over here, and once we add the 8 and the minus 10, we're going to get minus 2 here. So it'll be minus 2 here, minus 2, minus 2, minus 2, minus 2. So we'll have minus 10, which is perfect, and we'll have 10 over here. So now we have a circulation problem. And notice we've got this extra 2 over here that we can send to any of these vertices because the remaining capacity here is 6 minus 2, and that's 4. Hopefully that's clear what's going on. Now we have a circulation problem. We don't have any demands. And so now we can determine whether we can satisfy that circulation problem, which in turn will say that we can basically satisfy the demands by setting something up similar to this. Now, as you hopefully recall, the way you now solve this circulation problem is to add a new source and a new sink. And I'm going to do that, but I'm going to change the picture around a little bit and hopefully make it a little clearer, because as you may remember from class, if you're not careful how you set up the picture, it's very confusing. So this picture's still pretty confusing, but hopefully it's a little easier to see what's going on. So what have we got? We've got our new super source over here, and we're sending 10 into the T. We also have to send 2 into each. Notice I flipped the customers and the products around in terms of where they are on the screen. I still have to send 2 to each of the customers from this super source because I've got to provide the supply that they're supposed to have. Then the middle edges that are black, those are just the same old edges that we had in between before. We have an edge between a customer and a product if the customer used that product and therefore can be asked a question about that product. The new wrinkle, if you will, or maybe the more confusing wrinkle, is now, remember, S is over here, and under the regime, we've got 10 flowing into here. There's only one edge out of T, so the 10 will flow along here. It'll get to the S, and there's a demand of S here, was a demand of S here at 8, and so we can ship 8 of the units down here. That's going to leave us to the 2 units that we need to get the extra 2 questions from, and these are the original edges from S to the customers that had a remaining capacity after we took out the lower bound of 4 on them. So these last 2 questions can be spread among these other green arrows. And then the last bit to understand is basically the part on the left with the red arrows represents the flow into the super sink. And so from each of the products, we're going to have a flow of 2 into the SuperSync, and from S, we're going to have a flow of 8. Now, those are the capacities, of course, in the picture. So the idea is that if we can run max flow now to get the flow from S star to T star, and we get a max flow of 18, that will mean that, in fact, we've been able to find a circulation, and that will trace back to the very original problem, that circulation will satisfy the idea that each customer will be asked at least 2 questions, and each product will have associated with it 2 questions. I hope this is clearer. It's certainly the clearest explanation I've been able to come up with so far. So hopefully this helps. See you on next class.